In this video, we will explore properties of logarithmic functions. The first two basic properties are a to the power log of m to the base a is equal to m. And another one is log of a to the r to the base a is equal to r. For the first property, you will notice that this exponential is with the base a and the power is a log of m with the base a. So they have the same basis. So the answer is m. For the second property, this logarithm a to the r, the expression a to the r is with the base a, and this logarithm is also with the base a. That's why the answer is this power r. So let us have some examples on the first property. For the first property, 2 to the power log of x to the base 2 is equal to x. So you will notice that this exponential is with base 2, and the power log of x is also with the base 2. So that's why the answer is x. Another is, if we have 10 to the log x, it's also equal to x. Why? Because this log x, if the base is not written, meaning that is a common logarithm with base 10. So we can rewrite this as 10 to the power log of x with the base 10, so they have the same basis. The answer is equal to x. And if we have e to the ln of x, it's also equal to x, because ln of x is a natural logarithm, wherein this is a logarithm with the base e. So we can write this as base e to the power log of x with the base e. So since they have the same basis, the answer is also x. So this is applying the first property. So let us have an examples for the second property. So the first one is log of 1 to the base a is equal to 0. Why? Because if this log is with the base a, we can write 1 with the base a as a to the 0. Since they have the same basis, the answer is 0. So that is why log base a of 1 is equal to 0. Another one is log of 10 to the x is also equal to x. As we know, since the base is not written, meaning this is a base 10. So we can rewrite this as log of 10 to the x to the base 10. Since they have the same basis, the answer is x. So the last one is, if we have ln e to the x, it's also equal to x. Why? Because this ln is a natural logarithm wherein the base is e. So we can rewrite this ln as log base e of e to the x. The answer is equal to x because they have the same basis. So these are examples of the first two properties. Let us have some more examples regarding these properties, and if you can familiarize with these values, then it will be better, but if not, you can just use calculator. So the first is 2 to the 0 is equal to 1. As we know, every non-zero number raised to 0 is always equal to 1. That's why e to the 0 is always 1. But e to the ln 1 is equal to 1 because we know that ln is log base e and they have the same basis. So the answer is this value, which is 1. Or if you can see the combination of e to the ln or ln of e, so the answer is the given expression, which is 1. So e to the ln of 2 is equal to 2 because e and ln are together. You can just drop this e and ln. So let's have another. Log 1 is equal to 0, so the base here is 10. So if the expression here is always 1, it's always equal to 0, like log 1 is equal to 0. Another is log of 1 is also 0. See, it's any base. This base 10, this base 2, the answer is always 0. Another one is ln 1 is also 0. This is log base e of 1 is equal to 0. So any logarithm with any basis of 1 is always equal to 0. Like log 1, log base 2 of 1, ln of 1, all of them are equal to 0. But ln e power 1 here is equal to 1, and ln e power 2 is equal to 2. So this 2 is related here because, as I said, if e to the ln or ln and e are together, the answer is this power 1. So this power here is 2, and the expression here is 1, the expression here is 2. So there's a pattern, so it's easy to memorize. Now let us simplify and evaluate this expression. So we combine all the different examples applying the previous properties. So let's start with the first term, 5 ln 1. So if you remember, ln 1, log 1, or log base 2 of 1, this is always equal to 0. So the first term is 0 times 5. So this is 0. The value of ln 1 is 0 because, as we know, ln is a log base e. Then we can write 1 as e to the 0, so they have the same basis. So the answer is 0. Then for the second term, so e to the ln of x squared. So len is log base e, and they have the same basis, so the answer is x squared. And as I told you, that when you have a combination of e to the ln, the answer is this expression. So the answer is x squared. Now, the third term is 3 len of e to the fourth. So ln and e are together again. So ln e, so the answer is this power, which is 4. So meaning 4 times 3, which is equal to 12. And then this 2 times 10 to the log of x. So you cannot multiply this bases because they don't have the same power. The power of 10 here is log x, but the power of 2 here is 1. So what you will do is, you can write this log x as a log base 10, like that. And then simplify this red one, this red expression. Since they have the same basis, the answer is x. So this is x times 2. And then for the last term, so we have 9. Then this is log base 3. And this must be transformed or written into base 3 also. So it's 9 log base 3 of 3 to the minus 1, because 1/3 is 3 to the minus 1. Now, since they have the same basis, so the answer here is a minus 1. So this red expression is a minus 1 times 9. So it's 9 times minus 1. Or you can just use calculator in finding this. So, simplifying this and writing in descending power, we will start with the x power 2. So that's the first one. And then next is the x term, which is 2x. And next is this first term is 0. Then we have a 12 here and a minus 9 here. So 12 minus 9 is equal to 3. So the answer for this expression is x squared plus 2x plus 3. So for other properties of logarithm, so we do have product property, quotient property, and a power property. So for the product property, log of the product of m and n, so that is equal to sum of their logarithms, log m plus log n. So if there's a log of the product, it's equal to a sum of logs. Warning, there is no log of the sum or difference. What we only have is log of the product, log of the quotient, and a power property. So it means to say this log of m plus n or m minus n cannot be equal to log m plus or minus log n. You cannot distribute this logarithm. For the quotient property, log of the quotient is equal to the difference of their logarithm. So log of m minus log of n. So you will start with the log of the numerator, then minus log of the denominator. But as a warning, there is no quotient of two logarithms. What we have is log of the quotient, not division of these two logarithms. So this log m divided by log n cannot be equal to log m minus log n. Another property is the power property. Log of m to the power r is equal to r times log m. So it means this power r with the base m, this r will be as a factor or as a coefficient of these logarithms. Warning, log of 3x power 2 cannot be equal to 2 log of 3x because this power 2 is not for the whole 3x. It is only for x squared. So you cannot put this power as a coefficient of this log. So they are not equal. Let us have example 1, and this is a true or false question. So for the first question, log base 3 of x plus log base 3 of y is equal to log base 3 of x plus y. So it looks like this is a sum of logarithms. What we know is, when we have a sum of logarithms, it will be a log of the product. It cannot be log of x plus y, meaning you distribute or you factor out the log. So they are not equal. So it means to say it is false. Because as we know, the log of x to the base 3 plus log of y to the base 3. So if we have a sum of logarithms, it will be a product xy. So log base 3 of xy. For the second question, 2 log base 3 of 5x is equal to log base 3 of 5x squared. So as you can see here, there's a coefficient 2 before the logarithm, and we know this coefficient 2 should be the power of 5x. So it looks like they are equal because it is a log base 3 of a squared of 5x. So this is true. For the third question, len of x minus y is equal to len x minus len y. It looks like this ln is distributed to x minus y, and as we know, there is no len of x minus y. So what we have only is a product. This should be a product, or this should be a quotient. So this is false because this len of x minus len y, this is equal to len of quotient x over y. For the fourth question, log of x divided by y. So it looks like this is log of the quotient. So is equal to log of x divided by log y. So it looks like this log is distributed to numerator and denominator, which is not correct. So this is false because this log of x over y, it is a quotient property, which is equal to log x minus log y. It's not equal to this. For example 2, let us write the logarithmic expressions as a sum or difference of logarithms and express all powers as factors. Then we have to simplify our answer. So for the first question, it's a log base 3 of 9x times the square root of x squared plus 1. As you can see, I put the colors on 9 and x and square root of x squared plus 1, meaning this is the product of three functions. The first is 9, the second is x, and the third is square root of x squared plus 1. Since all of this is a product, we can apply the product property at the same time. So it's a log of these three functions. So log of the product is equal to the sum of these logarithms. So the first log is a log 9 base 3. The second is for x, which is log of x base 3. And the last one is the square root of x squared plus 1, which is log of square root of x squared plus 1 base 3. The next, as it is mentioned here, we have to simplify our answer, meaning if we can evaluate the expression, we have to evaluate. And the first term can be evaluated because there's no x. And we can use calculator in finding this, or if you want, we can change this 9 with a base 3 so we can easily evaluate. So we can write this as log base 3 of 3 squared because 3 squared is 9. So we choose a base 3 because of this base 3. So the answer here would be this power, which is equal to 2. So let us write that later. And then for the second term, we cannot do anything here. We will just copy this because it's log x base 3. And then for the last term, since it's mentioned here that we should express all powers as factors, and we can see that this square root can be written as a power 1/2. So let us write this as log base 3 of x squared plus 1 power half. And then now we can simplify our answer. The first term will be 2 and the second term will be the same, and the last term we have to express the power as a coefficient, which is 1/2 log base 3 of x squared plus 1. So that is how you will expand or write this given as a sum difference of logarithms. For the second question, we have len of x squared times x plus 2 divided by e to the 2x. As we can see here, we can check the operations. We can see a quotient. In the numerator, there's a product. So meaning this is a combination of a product and a quotient. But we can expand this in just one step. For example, so this given is len of x squared plus len of x plus 2, then minus len of e to the 2x. So how? Because all the expressions in numerator, so they have positive ln or positive log. So it's positive ln of x squared, then plus ln of x plus 2, because these two expressions are in numerator. And then the expressions in the denominator, they will have a minus log or minus ln of e to the power 2x. So that's how you will write this in just one step. And then, so let's simplify one by one. For the first term, there's a power 2, and we can write that as a factor, which is 2 ln x. And then for the second term, we will copy this because we cannot distribute ln in x plus 2. As we know, there's no ln of the sum. Okay, what we only have is ln of the product, ln of the quotient, and the power property. So we will write the second term as it is. And then for this is ln of e to the 2x. If you remember, when ln and e or e to the ln are together, so this is ln e, so meaning the answer is 2x. Because we can write ln as log base e of e to the 2x. See, you can see here that they have the same basis. That's why the answer is 2x. Or simply, what you can do is, if you know that this is ln with e, then the answer is 2x. Or e to the ln, then the answer is that power or that expression. So looking at this step, so 2 ln x plus ln of x plus 2 minus 2x, we cannot simplify this anymore. This is the final answer. Now for the last example, in this example 2, so the given is log base 3 of cube root of this expression. And as you can see in this expression, it looks like it's complicated. And as you can see, the denominator, we can still factor. So it means we may simplify this. So let us start simplifying this before expansion. So log base 3 of cube root of, the numerator can be factored as x minus 1 and 2x plus 1. The denominator can be factored as 9 times x minus 1. And then as you can see, there's a common factor which is x minus 1, so we can cancel out them. And then you can also write this cube root as a power. So we have a log base 3 of 2x plus 1 divided by 9 power 1/3. This power 1/3 is because of this cube roots. Then we can express the power as a coefficient, so we can have 1/3 of log base 3 of 2x plus 1 divided by 9. And as you can see here, this is a log of quotient. It means to say we can simplify this as 1/3 log of 2x plus 1 and then minus 1/3 log of 9. So we put this log of quotient as difference of log, and this 1/3 is distributed to each term. That's why there's also 1/3 on the second term. So looking at the first term, we cannot simplify this anymore. We can leave it as it is. And then for the second term, we can see that we can simplify this using calculator. Log of 9 is equal to 2 times 1/3 is 2/3. Or you can write this log 9 as log 9 of base 3 as log of base 3, 3 squared, and the answer is equal to 2. Then 2 multiplied by 1/3, the answer is 2/3. Now for the third example, we have to write each logarithmic expression as a single logarithm and simplify our answer. So here it is given with 4 logarithms with plus and a minus, and we have to write this in one log. So the first thing that we have to make sure is if they have the same basis, and another one is if the coefficient is 1 or a minus 1. So it looks like the coefficients are 1 and a minus 1. So now we will do the shortcut in writing this into single logarithm. So we can write as a log base a. So the numerator are the expressions with a positive log. And you can see that the positive log is these first two terms. So the expression here are x and 9. So the numerator has 9x. And then the denominator are the expression with a negative log. And these are the last two terms. So we can write this 5 and x squared plus 1 in the denominator. So that's how you will write this in one logarithm. For the second example, we have 1/4 log of x to the base 5 minus 3 log of x minus 1 to the base 5 plus 1. So first, we have to make sure that they have the same bases. It looks like this last term, we should write this as a log base 5 to combine as one log. And another one is the coefficient of log must be 1. So it means to say this 1/4 should be applied with the power property. So 1/4 should be the power of x, and this 3 should be the power of x minus 1. So let's do this step by step. So first is we have to make sure that the log is 1 or minus 1, okay? And then we are rewriting this 1/4 of log of x to the base 5 as log of x to the 1/4 base 5 by putting this coefficient as a power of x. And then the second one is putting this 3 as a power of x minus 1. And then the last one is, as we said, we have to change this into same log base 5. So log base 5 of 5 power 1. So if you will simplify this, the answer is this one. Okay, so the base is 5 because this is log base 5, and I have to write this with the base 5 as well, and the power must be 1 because this is 1. If this is 2, then the power is 2. If this is 3, then the power is 3. So now this expression is now all logarithms in base 5. So I can write this as in 1 log base 5, and the numerators are the expression on the first and last. So we will write this x to the 1/4 as 4th of x, and this 5 power 1 as 5. So these two expressions are in numerator. And then for the denominator, it should be an expression with a negative log, which is the middle term. So we write this cube of x minus 1 in the denominator. So this is the final answer, and you cannot see any common here. Now for the last example of this question, so we have three logarithms, and let us make sure that they have the same basis. Yes, and let's make sure that the coefficients are 1 and a minus 1. That's right. So we can now write this in one logarithm with the base 2, and the numerators are the expressions that are positive log, which is the first and the last. So x plus 1, and then square root of x minus 1. And then the denominator are the expressions with a negative log, and there's only one term, so it's x squared minus 1 should be written in the denominator. Then after that, we have to make sure that this is in simplest form. It looks like we can still factor x squared minus 1, and we can write this square root of x minus 1 as a power 1/2. So let us do that. So the numerator is x plus 1 and x minus 1 power half, and denominator is x plus 1 and x minus 1. So as you can see here, we can simplify by canceling out the common factor, which is x plus 1. And then for this term, what we're going to do is dividing with the same base, you have to subtract the powers. So the power half minus 1 is a negative 1/2. So we now have log base 2 of x minus 1 power negative half. Now, if you will analyze whether this is the final answer, since there's a negative power, means this is not yet the final answer. So what you can do is, to get rid of this power negative half, put this as a coefficient by applying the power rule. So this will give us negative half of log of x minus 1 to the base 2. So this is the final answer because we cannot do anything on this step. Now, the next property is the change of base formula. So this change of base formula is needed depending on the given logarithm. If the given logarithm is a base 2, and the other one is a base 4, then you have to change with the same base. So that's why we can apply the change of base formula. So meaning we will apply this change of base formula only if needed. So for example, if I have log of m with the base a, and I want to change with the base b, so let's say the requirement is base b, so meaning this is equal to log of m divided by log of A with the base B. Uh, this base B can be a common logarithm, which is base 10. That's why this log M over log A with the base B can be log M divided by log A only, meaning I choose the base 10. I can also choose changing this logarithm with the base E. So meaning ln of M divided by ln of A. So one example is if I have log of 2 to the base 3, I can write this as changing to base 5. Let's say I want a logarithm with the base 5, not the base 3. So I can change this as log 2 divided by log 3, both of them base 5. If I want to change this logarithm with the base 10, means I would just write this as log 2 divided by log 3. And then if I want to write this logarithm with the base e, means I can just write this as ln of 2 divided by ln of 3. You can try putting this in calculator. This fraction and this fraction and that fraction, it's equal to the value of this log of 2 to the base 3. So let us apply those properties that we learned and including the change of base formula. So suppose, for example, we have ln A equal to 2 and ln B is equal to 4 and ln 2 is equal to S and ln 3 is equal to T. So without using calculator, let us evaluate this example. So ln of 6A divided by E squared. So what we need to do is to write this expression with this given. So it means to say we have to expand this. We have to write this as a sum or difference of two or more logarithms. So since we can see a quotient here and a product, so we can directly write this in one step as same as these expressions in numerator is positive ln and all the expressions in the denominator are negative ln. So it means to say we have ln 6 plus ln a minus ln of e squared. So as I said, the expressions in numerator with positive ln, expression denominator with negative ln. And then now we have ln a which is equal to 2 and this ln e squared we can simplify this as power 2 because ln and e are together, so the answer is this power. But this ln 6, there's no given ln 6 and do not put this in calculator. So what you're going to do is you can factor 6 with 2 and 3, meaning 2 times 3. So ln times 2 times 3, then copying the second term and just rewriting this with the log base e in case you don't know the answer for this third term, or you can just write directly this as 2. So this ln 2 times 3, it's a ln of the product, which we can write it as a sum of ln. So ln 2 plus ln 3 for this first term. And then copying the second term, and then this ln e squared is equal to 2. So now we can now simplify this or rewrite this into this given expression. Ln 2 is S, then ln 3 is T, ln A is 2, and then minus 2. So we are writing this as S plus T plus 2 and the minus 2, and 2 minus 2 is 0. So the final answer is S plus T. So that's the answer for this first logarithm. For the last example, we have given us log of 24 to the base b. Log base b is not ln. This is a logarithm with the base b. And here in the given, there's no given logarithm base b. It's everything with ln. So it means to say we will have an idea that we can use the change of base formula, because what we want in this log base b of 24 is to change with the base e to make it ln. So we have ln of 24 divided by ln b. And then this ln b, we can directly substitute that as 4, but this ln 24, we have to factor this 24 just like what we did here in 6, putting it as 2 times 3. So we have to factor 24 as 2 cubed times 3 because 2 cubed is 8 times 3 is 24. Then after that, we can apply a property here. This is ln of the product. We can make it as a sum like this. And then Since there is no len of 8 and len of 2 cubed here, okay, do not write this as s squared. Len 2 is s. This is len of 2 cube. It's different. Okay? This is not cube of len 2. This is len of 2 cube. So what we can do here is to apply the power property, putting this 3 as coefficient of len. So this is 3 len 2 plus len 3 divided by len b. So now this len 2 is s. So 3 times s plus len 3 is t. So we have a 3s plus t divided by 4 because 4 is len b. So this is the final answer for this question.